Hi, this is your host Swapnil Bharti, and we are here at SUSECon in Nashville, Tennessee. And today we have with us Jerry Melnick from SIOS. Did I say it right?
You said it perfectly.
Thank you. So now you can hire me, right? So first of all, tell us, what does the company do?
The company is involved in high availability infrastructure software, high availability clustering, which has been around for years. We were the first providers of a Linux clustering solution in early 2000. So basically one of the first high availability clustering solutions, if you're familiar with those.
Right. When we look at high availability, what does it mean? It could mean different things in different contexts.
Right.
So, what is the pain point where you do need high availability?
Well, what you're really looking for is on critical applications, the ones that your business depends on. If that goes down, you're going to lose money, you could get fired, or you're going to be up all night trying to fix it, right? So if you think about a single server, when that goes away, what do? You go order a new one. If you're in the cloud, you got to go build yourself a new environment. How do I build redundancy into an application so that it can automatically recover in a matter of minutes and guarantee a certain amount of uptime and no data loss over the course of a year?
Not in matter of seconds, in minutes.
In minutes.
At least it's not in hours and days.
Right,
Traditionally would have.
You know, the sort of formal definition of high availability in the stack of fault tolerance, high availability, just regular old availability, and backup and recovery. High availability is a 4 nines implementation. 4 nines means 99.99% uptime, and that translates to no more than 58 minutes a year downtime and no data loss. So from a sort of academic perspective, that's the definition. There's a lot of people who talk about 4 nines. It's a marketing term, but high availability and high availability clustering is designed to deliver that level of availability. So there's things like SAP systems, Oracle systems, those kind of critical databases that your business runs on. If it goes down, it goes down for too long, or you lose data, you're in big trouble.
Yes. What are the businesses which are really running those mission critical innovation where they cannot afford? Because we have seen AWS goes down, Netflix goes down, YouTube goes down.
Sure.
But what are the businesses that cannot afford so that high availability makes sense in those cases?
Well, I mean, just about every business today in the digital economy, right, is reliant on some level of computing resource that if it's not there, you can't take an order.
Right.
You can't manage an emergency call. You can't, open a parking gate. I mean, you can imagine the kinds of systems that are out there that we're dependent on today, and it's more than ever before. So the question is not necessarily how big the system is, it's what's the mission of the system and how does it relate to your company. So it's a small company, a large company, it goes out, you lose business, you potentially lose your company. Disaster. Everybody's familiar with disasters, right?
Right.
So this is the same sort of idea, but on a much more smaller, much more tighter time constraint.
So let's talk about, how do you solve this problem, about your product portfolio in a way that today's world we see, you can spin a new container, if a service goes down. But in this case, how do you ensure not only recovery, or redundancy, plus also that, how do you know that, something went down as well? I don't know, monitoring, logging, I don't know what are the core components that play a big role.
So the heart of any availability system is redundancy, right? I got to have 2 of it, so if one disappears, otherwise I got to go find something and fix it up real fast. So if you want to get it up fast, it's got to be up and running. So the key is it's not just one technology, it's a package of technologies that both detects, understands the problems occurred, and it could be at any level. It could be in the application stack, it could be in the network stack, it could be in the storage stack, it could be any combination of all those. You need to detect the problem. Once you've detected the problem, you need to decide, what do I do about it? Ideally, I don't do anything other than restart the smallest thing possible. So say if a service stops, if I detect a service stops, I just restart the service. But if a server stops or a storage device stops responding or the database has a problem, I might have to take much more drastic steps, and that would include recovery to another server. So in that case, what we're doing is covering both detection, orchestration, and recovery all in one solution, in a turnkey solution. And then we're making sure on the recovery side that the restart of all the services and their dependencies, like the database has to be up before the application can start, the network has to be available before the database can start, etc. All that stuff is orchestrated so that you get minimal recovery time and maximal reliability. Because an unreliable recovery system or unreliable high availability system is useless.
Right.
And so people forget that. So it actually is highly sophisticated if you're going to really put this together and meet your mission of a reliable recovery, right?
So is it cloud native technology, or you done on your data center on-prem, or?
Oh, so what really what's really unique about our solution is we can run on-prem and physical servers. We can run in VMware. We can run in cloud. We can run anywhere between. We can run any kind of application. So we call it clusters your way. And HA and DR are not mutually exclusive. DR. People get confused a bit about this at times, but DR really is a recovery point. Will I lose any data on my recovery?
Yeah, exactly.
Now, in a DR situation where you have a data center that's very far away, the speed of light becomes a problem. You can't replicate data fast enough to actually keep that guy up to the second without impacting performance in your primary site. So we have customers, a more and more common use case will say, I want HA within, say, an Amazon or Microsoft region and across to availability zones. And that gives me very, very low latency connections between two data centers that are 10 miles apart. That gives me HA, and I know I can recover fast if the whole region were to go down.
Right.
I have a third node, because you can have more than one extra node. You can have a third node in a DR region that has asynchronous. So in the case of a catastrophic failure, you may lose some data, but you can recover, and you don't have to go to backups, and it might be 5 minutes of data.
Right.
It's not days of data. So,
Right.
So that kind of covers all the use cases.
And as more use cases or more customers are moving to or embracing emerging technologies or IoT and all those things, so a lot of I don't know processing, but a lot of things are happening at the edge.
Sure.
So does HA make sense there as well? And if you just, how do you?
Yeah, I mean, certainly it depends on how you're orchestrating what's at the edge and what they're doing. And
Like let's take example of autonomous car.
Yeah.
That's a totally different use case versus a sensor on the door.
Well, but in an autonomous car, the car itself has redundant components at electrical
decisions
levels,
are made
right?
locally.
Right.
Yeah.
So they've actually done availability locally, and there may be some connection to some. But a little bit more interesting in that question is people will say, well, new applications, there's database as a service and things like that. And, as you said, containers, and how does that fit in? And quite frankly, where we're playing more importantly is there's a huge number of legacy applications that are out there that are going to look for a new home outside of their data center for any number of reasons.
Right.
The data center's closing, I need IT flexibility and agility, and I'm going to look to a cloud provider to give me that. And do I have to re-architect my application in order to move it, or can I just lift it up, put it in there, and have the same type of availability I've enjoyed on premise in the cloud? And we help those customers.
Okay.
And those applications are an important part of our economy, no doubt. And
Right.
We
have been talking about digital transformation for a very long time.
Yes, we have.
But I think there are still a lot of companies, they're like 100, 200-year-old companies, they still have a lot of legacy, luggage with them. So how do you help them,
And that's really that use case where you say, hey, you've got some servers, maybe you're using high availability clustering for your Oracle database on your premise, and you've got shared storage in there, and they have failover across just classic high availability clustering. You have shared storage device, 2 servers, one fails, you fail over, you got shared data still there. Those guys will come to us and say, hey, we want to do the same thing in the cloud, but there's no shared storage in the cloud. Can you help us? And that's where our technology says, yeah, you don't need shared storage. We can do that without shared storage. We kind of virtualize that storage layered on top of the cloud across availability zones and regions. So we do it transparently, and that's how we help them and why they come to us.
Perfect. I think I have touched upon some basics to understand what you're doing. Is there anything else you would like to touch upon beyond that?
Well, the observation that we're making, to be honest, is that you would think, well, everybody's going to the cloud and it's all there. Well, if you think about it, the sort of most important applications, those are the things that keep IT guys up at night. And if you say to them, hey, let's take that one and go to the cloud, they're sweating.
Yeah.
Because they're going, yeah, the cloud, I have no control of that. And you're saying I want to do that. So in the last 2 years, there's been a profound change. And I wouldn't say it's a stampede by any means. It's the very leading edge. And people are taking the leap with things like SAP, large Oracle databases, critical Windows systems, that they want to move to the cloud, and we've been helping them. And so we see sort of a wave of that coming. And it's not going to, it's going to start slow, but at some point, lure of the cloud and its value is going to bring people around, and there's enough use cases where they've been very successful at that. You're going to see that really be a big thing. So the cloud becomes a utility for even the most critical applications.
Right. Okay, before we wrap this up, I want a fun question, which is more about what are your hobbies, what you do in your free time, if you have any free time?
I have no free time anymore, but I was deeply involved in woodworking and lots of other fun activities at home. But
not anymore?
Now I'm excited about these opportunities, and my time is spent.
So this has become your hobby now?
This is my hobby, my passion.
Awesome.
Yeah.
Thank you once again for talking to me today, and
absolutely.
hopefully we'll see you again in the future.
I think so.
Yeah.
I think so. Thank you.
Thank you.